This final chapter, Chapter 6, contains 6 quiz questions to test your understanding of the materials we have covered. Question 1. Using a LIBOR curve that lies completely flat at 6%, calculate first the rate on the fixed leg of a 7-year semi-annual spot starting swap. Then, assuming the same vol input of 30% we used for swaptions throughout the module, combine a 7-year off-market rate swap with a 2x5 receiver swaption to engineer a 7-year IRS cancelable on its second anniversary at the option of the fixed rate pair, such that the NPV of the aggregate package is 0. What is the strike of this cancelable swap accurate to 2 decimal places? The 4 permissible answers are here. Solution to question 1. The LIBOR curve being flat at 6% means that all swap rates, whether spot starting or forward starting, lie at 6% as well. No spreadsheet is needed for this conclusion. We turn now to worksheet Q1 solution, which shows the pricing for the cancelable swap and is identical to our previous worksheet extendable swap, except for having a 7-year swap rather than a 2-year swap priced in cell L14, and for amending the formula in cell L18 for the cancelable swap to reflect the sum of the 7-year swap at K% plus the 2x5 receiver swaption versus the payer swaption previously at K%. Goal seeking the value in this cell to 0 by changing the strike leads to a solution of 7.2256%, a number that appears all too familiar. Indeed, it is the same solution as for the extendable swap, since a 2-year extendable at the holder's option to 7 years is exactly the same as a 7-year cancelable at the holder's option after 2 years. The diagram that has just appeared confirms this by showing the swaption holder on day 1 entering into a 7-year IRS with the bank, whose fixed leg is 7.23%, rounded from 7.2257%, remembering that he also purchases from the bank a 2x5 receiver swaption struck also at 7.23%. 2 possible scenarios exist. Scenario 1, the holder exercises the receiver swaption after 2 years, presumably because 5-year swap rates in the market are below 7.23%, so now has 2 swaps in place with the bank, but whose cash flows until their maturities are completely offsetting to the nearest dollar, so in effect has no remaining cash inflows or outflows, and again is in exactly the same position as with the extendable swap when he did not choose to extend. Scenario 2, the holder does not exercise the receiver swaption after 2 years, presumably because 5-year swap rates in the market are above 7.23%. So the original swap remains in place for the entire 7 years, and the end result is exactly the same once again as we had with the extendable when the borrower chose to extend after 2 years. It is, of course, put-call parity that brought about this result. More generally, a swap with a maturity of M years, extendable at one party's option for N additional years at the same fixed rate, is exactly the same in cash flow terms as a swap with maturity M plus N years, having the same fixed rate as before, but cancelable in that party's option after M years. The shape of the curve, incidentally, does not affect this outcome, which is true whether the curve is flat, positive, inverted, or humped. In summary, the correct answer is C, as in Charles. Question 2. Please answer this question assuming the same market data as in worksheet callable bonds. You are offered a 6.5% 4-year bond paying annual coupons and puttable on each anniversary by the investor to the issuer at 98 on the first anniversary, 99 on the second, and 100 on the third, in each case plus accrued and unpaid interest. What is the fair value of this bond? You will need to adapt the binomial models provided for callable bonds so they can be used instead for puttable bonds. Here are the 4 permissible answers. Worksheet Q2 solution is modeled after our earlier worksheet for cancelable bonds. Note, however, this time the word puttable in the tree starting on row 41, and also the various strikes under the put option in cells D44, D45, and D46. More importantly, we enter the formula in cell F48, for example, and observe that we have correctly replaced the min operator with max in this and all other relevant cells. This reflects reality for a puttable bond, which cannot trade below the relevant strike price on any exercise date of the put option, plus accrued interest as usual. Otherwise, an investor would simply purchase this bond in the market and immediately earn a riskless profit by putting it to the issuer. The spot price for this bond is revealed in the cell C48 to be 105.219, consistent with answer D as in David. Question 3. The 5-year swap rate is 5%, while the 10-year swap rate is 5.5%. A borrower with floating rate debt enters into a 5-year swap with HSBC, but which can be extended in HSBC's sole discretion for 5 additional years at the same fixed rate as for the first 5 years. Which of the following is true? You may not use any spreadsheets to answer this question. Here are the 4 permissible answers. Solution to question 3. This problem leaves a significant majority of people confused, many of whom are inclined, perhaps understandably, to assume that the positive shape of the yield curve might push the fixed leg of the extendable swap above the 5% level of the spot starting 5-year swap. But a simple observation dispels this illusion. As we saw in the module earlier, an extendable is the sum of a spot starting swap plus or minus a swaption. And in this particular case, the borrower has entered a spot starting 5-year swap at, let us say, K%, but has also sold to the bank a 5x5 European receiver swaption with strike K% as well, where K must satisfy the equation you see here. Without knowing anything about the shape of the curve and about interest rate volatilities, we know that the 5x5 swaption at inception, like any other option, must have a positive PV from the holder's perspective, i.e. the bank's. Thus, the spot starting 5-year swap must have a negative PV for the bank. For this to happen, this swap's fixed leg must lie below the market rate, hence below 5%. Thus, the correct answer is A. Question 4. Using a LIBOR curve that is completely flat at 5% and a 30% vol for all interest rates, determine the rate on the fixed leg of a 5-year semi-annual interest rate swap for a borrower who wishes to pay fixed and is eager to earn a subsidy by granting to the bank the right to double the swap's notional amount on its first anniversary for its remaining life. Here are the 4 permissible answers. Solution to question 4. While this structure, referred to sometimes as an expandable swap, was not specifically discussed in the earlier chapters of this module, you are expected to intuit that the bank's right to double the notional is nothing more than a long position in a 1/4 European swaption struck at the same fixed rate as the rate for the original swap. If the bank exercises this option, the notional of the swap for its remaining life doubles, since the swap underlying the swaption and the original swap have identical terms from that point until maturity. As in question 3, since the swaption has a positive PV from the bank's perspective on day 1, the original off-market swap from the bank's perspective must have an equal and opposite, i.e. negative, PV. So the fixed leg paid by the borrower must be below the market rate. Worksheet Q4 solution is very similar to our earlier one for extendable swaps, with appropriate changes made in the labels and formulas for various cells to reflect, among other things, of course, the 5% level of the curve, also that the original off-market rate swap now has a 5-year tenor, that therefore in computing its PV we discount it using the sum of 10 discount factors instead of 4 previously, and that the swaption we are pricing now is a 1/4 receiver swaption. Goal seek, setting this cell at the bottom equal to 0 as before by changing the strike, now leads us to a 0 NPV for the expandable swap when the fixed leg is 4.6684%. Therefore, the correct answer is B as in boy. This expandable version of an IRS appeals to borrowers who have no strong view on what maximum percentage of their floating rate debt should be swapped into fixed. Take, for example, a borrower with 1 billion of debt in aggregate, all of it currently floating, who is determined to swap at least $300 million of it, but is prepared to reach $600 million if the right incentive is available. This borrower could find very appealing the idea of an immediate 32 basis points of savings under the first 300 million swap he initiates, his downside being only that if rates have declined by the first anniversary, the notional of the swap would double, but only at the same fixed rate as the original one. Of course, by that time, 4.68% may not be that attractive relative to market rates for 4-year swaps. Question 5. Assume a completely flat LIBOR curve at 4% semi-annual and an annualized volatility for interest rates of 40%. Assume also, as we did in Chapter 5, that Fannie Mae is rated AAA and can issue non-callable debt for any maturity at the swap rate flat or LIBOR flat. Assume finally that Fannie Mae debt debt containing a European call option of any tenor requires a 30 basis point coupon premium for successful placement. How much would the issuer save in basis points annually if it issued a 5-year bond, paying coupons semi-annually and callable on its first anniversary, and immediately sold an appropriate swaption to lock in guaranteed 5-year fixed rate funding under any interest rate scenario? You are encouraged to use the same approach we used in Chapter 5 to answer this question. The 4 permissible answers appear now. Solution to question 5. The 30 basis point coupon premium required of Fannie Mae for callable debt means that the issuer will issue the 5-year bond callable in 1 year at a coupon of 4.3% semi-annual. So Fannie Mae will seek to monetize the option embedded in the bond by selling a 1/4 receiver swaption struck at 4.3%, which will earn Fannie Mae an annual 64 basis points, as we will demonstrate in just a moment. Worksheet Q5 solution prices a 1/4 receiver under the assumption of a 4% flat LIBOR curve and 40% swaption vol, revealing an upfront premium of 2.8813%. This is visibly substantially more than the PV of the extra 30 basis points Fannie Mae is paying on the callable, even if that instrument remains outstanding for the entire 5 years. Indeed, if we annuitize this upfront premium over 5 years semi-annually at a 4% semi-annual annuitization rate, as we do in cell L15, we find it is equivalent to around 64 basis points annually, so visibly well above the coupon premium of 30 basis points under the callable bond. Let us, as before, examine the 2 possible scenarios for Fannie Mae and determine the all-in cost over 5 years for the issuer under each. Scenario 1, on the bond's first anniversary, the 4-year swap rate is above 4.3%. The bank will therefore let the swaption lapse. Fannie Mae, in turn, would have no reason to call the bond and refinance it at a higher rate, so would leave it in place for the remaining 4 years. Our diagram shows clearly that this leaves Fannie Mae paying 3.66% fixed on an all-in basis. Scenario 2, on the bond's first anniversary, the 4-year swap rate is below 4.3%. The bank will therefore exercise the swaption and enter into a 4-year 4.3% IRS with Fannie Mae, under which Fannie Mae receives LIBOR and pays fixed. But Fannie Mae can offset this by calling the bond and replacing it with a 4-year FRN paying LIBOR flat. Our diagram again shows clearly that all this leaves Fannie Mae paying 3.66% fixed on an all-in basis. So the correct answer is C, as in Charles. Question 6. Turkey can borrow at 5% for 5 years in either euros or US dollars. Spot and forward FX rates for euro dollar are 150 for all maturities. Since the country has significant remittances in both of these currencies from a combination of exports, mostly in US dollars, and worker remittances, mostly in euros, Deutsche Bank proposes to Turkey that it borrow 100 million euros for 5 years at 3%, provided that on the loan's first anniversary, Deutsche can, in its sole discretion, convert half the loan into a 4-year US dollar 75 million loan at 3%. And on the second anniversary, Deutsche can, in its sole discretion, convert the second half of the loan into a 3-year $75 million loan, also at 3%. How might you deconstruct the loan described above? Here are the 4 permissible answers. Solution to question 6. To achieve the 2% subsidy over normal 5-year rates, Turkey must have sold optionality to Deutsche, not bought it. And since it appears each right to convert a portion of the loan into US dollars can be exercised on one specific date only, these are European options, not Bermudan. In fact, in addition to borrowing 100 million euros for 5 years, Turkey has sold to Deutsche first a 1/4 cross-currency swaption, enabling Deutsche on the loan's first anniversary to initiate a cross-currency swap with Deutsche, under which Deutsche will deliver euros and receive dollars, with notionals of 50 million euro and $75 million. And 2, a 2/3 cross-currency swaption, enabling Deutsche on the loan's second anniversary to initiate a cross-currency swap with Deutsche, under which Deutsche will deliver euros and receive dollars, again with notionals of 50 million euros and $75 million. The premium Turkey earns from selling these 2 cross-currency swaptions is built into the loan and brings down the interest rate to 3% in either currency. Therefore, the correct answer is C. This completes the quiz, part 3, and of course, this entire module on callable bonds and swaptions.